Hello everybody. So, okay, without wasting our time, we will be starting with the next topics in SOM, that is the Poisson's ratio. Okay, so we will see that what is the significance of this ratio. Okay, so well, if you write uh, the Poisson's ratio, I'm sorry for my pen, Poisson's ratio, right? Okay, so now suppose if you see a rod, take a rod of some length L, and if we apply a force out here, say P, then obvious the length will increase. Yes, let the length will increase by say delta L. Okay, that's all. अभी कहानी बाकी है मेरे दोस्त. The length will increase along with the decrease in the dia. Yes, this rod has got the initial dia, say D 5. These are 5. Okay. So the dia will also get decreased, right? Means the length will increase and dia will decrease. Means what? That there is a linear and, or we can say, or longitudinal strain, right? But the dia is also get decreased, so this is known as the lateral strain, or in few words we can say that the strain in lateral direction. Yeah. Okay, so we have got the two strains in this way, delta L by L and delta D by D, right? Okay, now we will see that what is the significance of this ratio. Okay, so the significance of this ratio lies in the ratio of lateral strain or the strain in lateral direction to the linear strain, right? Suppose if you write the Poisson's ratio as mu or 1 by m, then it is your lateral strain by linear strain. Means delta D by D upon delta L by L, right? So this is all about your mu, right? Now, how do we employ this ratio in our numericals? Okay, fine. Suppose I take a block, say side L, right, and let it be a rod only. Okay, say the dia of D, right? You are being asked in the numerical that what is the value of lateral strain or is in dia if the Poisson's ratio of the material is mu. Okay, so we have to find out the decrease in dia, that is delta D. Okay, and we are having 1 by m or mu or nu, that is equal to delta D by D upon delta L by L. Okay, fine, right? So we have applied the force P, right? We know by the value of delta L is equal to PL by A, right? Right? We know this well. Okay. From here, we can find out the value of delta L, and delta L by L, it can be it can be found out in the second step, right? And after finding out the delta L by L, we can go for the value of the ratio 1 by m, and delta L by L, as we have calculated, we have to find delta D by D. D also we know, right? So in fact, we are being left with finding the value of delta D, and that can be found out very easily by 1 by m into delta L by L into D. Fine. So from here, we can get the decrease in dia, right? Right? And if you are being told now to find out the value of the lateral strain also, then obviously it can be found by using delta T by D, right? So this is one of the significance of this Poisson'S ratio. Okay. Now I will move further and we'll see that what happens next. Okay. Suppose if we have a block, yeah, okay, suppose we have one block, right? Okay, fine. Its sides are A, P is the width, and C is the height, right? Okay. So the volume is what? It's A into B into C. So means it is a cuboid, right? Perfect. Okay. Suppose if we apply a force out here on this surface, on the shaded one part, the shaded area is what? The shaded area is B into C. Wow. So it means that the force P is being applied at the shaded area B into C, right? Shaded area B into C. Okay, fine. So means that there will be increase in length of A, side A. Why? Because the force P is acting at 90 degree to B into C. Okay, so the length means the length out here will be your A, that will increase. Okay, that will increase, right? Now suppose if we take, so this is the case of the uniaxial stress, right? And if you are being asked that what is the value of the lateral strain when a block is being subjected to the uniaxial stress, I will write the question that what is the value of lateral strain when force P is being applied at the surface B into C. Okay, fine. So we know that the linear strain, that is the change in the side A, yani delta A, right? It can be found out by the use of delta L, that is your PL upon A, right? So it means that it will be delta A is equal to P into A upon AE, right? Right. And you are knowing the value of this material. Let the value of the Poisson's ratio is mu. Okay. So in that case now we have to find out the value of the lateral strains, and to find out the value of the lateral strains, what we have to do is apply the application of the Poisson's ratio, that is the mu. Okay, how? Right. Okay, suppose So this was our block. Right, and this was your A, this is your B, and height is C. Our force is being applied on this shaded area. Okay, right. So delta A is equal to P into A upon A. Right. Okay. Suppose this is the mu, the value of the Poisson's ratio. Now delta B by B upon delta A by A will give you the value of mu. So from here we can find out the value of delta B. Okay, right. In the same way, if you are being asked that what is the value of delta C, same way delta C by C upon delta A by A, that will give you the value of mu. Okay. Okay. Now I have one doubt that what should be the magnitude of the lateral strain? What should be the magnitude of the lateral strain? Right? Oh my God. तो इसका अर्थ क्या है कि अगर मान लीजिए मैं लेता हूँ डेल्टा बी बाई बी का अपॉन डेल्टा ए बाई ए लेता हूँ इज इक्वल टू म्यू है, ठीक है, राइट. सो delta B by B will be given as mu dot delta A by A, right? Okay. From this formula, what we can infer is that the value of this part will be negative. Why? Because if the length is increasing, then the breadth and height should get decreased, right? Okay. So if the length is increasing, the value of breadth, or we can say width and height will decrease, right? Wow. So it means what? That the value of delta A will be negative, right? Okay. So get it nullified. To get it nullified, what we do, we put negative sign in front of this ratio, right? So means what? That this delta B by B upon delta A by A will be obvious negative. So we put simply out here the negative sign. So that will come as mu, the value will be coming in the form of the positive one, right? Fine. So if you are being asked that what is the value of this lateral strain, so it will be mu dot delta A by A. Fine. It was the case of the uniaxial stress, right? So if you want, I will get it revised. We have a few things in our hand. The three different types of cases. We will see it our first case, second case, and the case third. In the first case, we will see uniaxial stress. In the second case, we will see biaxial stress, and in the third case, we will see triaxial stress system. Okay. For the uniaxial stress means what? Suppose this is a block and only one stress is acting on its sigma x. Suppose. In biaxial, we have the two different stresses acting in the two opposite directions, or the different directions, sigma x and sigma y. Nature can be same or different. Nature can be same or it might be different also, right? And magnitudes can be same or vary, is as per your wish, right? Okay, nature, it can be same or the different. Now what is the meaning of nature out here? Lateral means suppose it can be your tensile and can be your compressive also. Okay, both. Right. Now we come to the triaxial system. So in this case, we have the three stresses acting on the axis. Right. Wow. So sigma x, say sigma y, and say sigma z. Okay. So to find out the strains, to find out the strains, to find out the strains in the respective sites, we employ Poisson's ratio. Okay. How? So how we do that? Suppose first I will take the uniaxial, as I have already explained with this one, but still I just want to get it revised. Suppose it's sigma x, right? Right. So the strain in the direction of sigma x is sigma x upon E. How is it? Why not? E is what? The stress upon strain, means sigma upon epsilon. So if you want to find out the epsilon, that would be sigma upon E. Right? Fine. Okay. So the strain in the linear direction, it will be sigma x upon E. Now, what is the strain in the lateral direction? So we know that the mu is what? Strain in the lateral direction upon strain in the linear direction. Minus sign will be here so that the value of mu will always come positive. Okay. So in that case, if you want to find out the strain in the lateral direction, so it will be minus mu the strain in the linear direction. So minus mu, it will be your delta L by L. Sorry, sigma x by E. Right. So we have found out that the strain in the lateral direction. I would like to write out here the strain in the lateral direction would be minus mu sigma x by E, and the strain in the linear direction will be sigma x by E. Okay. Right. It was the case of the strain in the uniaxial stress system. Okay, fine. Now we come to the biaxial stress system. Biaxial stress system. Okay. So suppose we have got a block. I'm going to take one of the front view of it, right? So this is your sigma x, and this is your sigma y. Okay. Right. So now if you want to find out the net strain in this block, net strain in this, we can say body. It means what? That strain in the direction of x plus strain in the direction of y. एक तो आपका ये रहेगा, ठीक है. सेकंड थिंग है क्या? If you want to find out the net strain in the body, in that case, the strain due to sigma x plus strain due to sigma y. Done. Now I would like to take the second part. It will be same, but I will explain you by the second part. Okay. So how? So I have told you that the net strain, it will be strain due to sigma x than strain due to sigma y. Okay. Now the strain due to sigma x, it will be what? Strain in the linear direction and strain in the lateral direction, right? In the same way, the strain due to sigma y is also the strain in the linear direction and the strain due to lateral डायरेक्शन. ठीक है, अब मैं आपको ये एक वे में और ना समझा दे सकता हूं, इफ यू वांट, राइट. सपोज करो कि ये आपके पास एक बाई एक्सियल स्ट्रेस सिस्टम है, सिग्मा एक्स है और सिग्मा वाई. ठीक है, मैं इसको दो भाग में तोड़ सकता हूं. ठीक है, एक में क्या है कि सिर्फ सिग्मा एक्स और सिग्मा एक्स है, और एक भाग में क्या है, सिर्फ सिग्मा वाई और सिग्मा वाई है. ठीक है, नाउ इफ यू वांट टू फाइंड आउट द नेट स्ट्रेन इन दीस टू सिस्टम्स, तो इस वाले में नेट स्ट्रेन है कितना. एक है तो स्ट्रेन इसके लीनियर डायरेक्शन में है, दैट इज सिग्मा एक्स अपॉन ई, एंड वन स्ट्रेन इन द लैटरल डायरेक्शन दैट इज प्लस माइनस म्यू सिग्मा एक्स अपॉन ई, right? This is the strain due to sigma x in the linear and the lateral direction. In the same way, the strain due to sigma y is sigma y upon e plus minus mu sigma y upon e. Ab, this is the equation suppose first and this is equation second. We will add up, we will got the summation of it, and we will see that then net strain it will be sigma x upon e minus mu sigma x upon e plus sigma y upon e minus mu sigma y upon e. This is the net strain in this body, right? Okay, fine. So it means what? Sigma x upon e plus sigma y upon e minus mu sigma x upon e plus sigma y upon e. So sigma x upon e, this can be taken outside and it will be 1 minus mu. Okay, fine. This is the value of the net strain in the body. Fine. Okay, now in the same way we will go for finding out the strain in the triaxial stress system. So again, I am going to draw a cuboid. Yes, which has got the sides A, B, and C respectively. The volume of the block will be A into B into C, right? Okay. Now what? Okay, so what is the net strain? Write this part. Strain due to, suppose here it is at least sigma x, sigma z, and sigma y. Sorry, y. Strain due to sigma x plus strain due to sigma y plus strain due to sigma z. Now strain due to sigma x in the linear direction, that is sigma x upon e. Strain due to sigma x in the lateral direction, that is minus mu sigma x upon e. Strain due to sigma y in the linear direction, that is sigma y upon e, and strain due to sigma y in the lateral direction is minus mu sigma y upon e. Strain due to sigma z in the linear direction is sigma z upon e, and strain due to sigma z in the lateral direction it will be minus mu sigma z upon e. We will get them all summed up, right? So the final expression that we will get this sigma y upon e plus sigma z upon e minus mu sigma x upon e minus mu sigma y upon e minus mu sigma z upon e. So we can take this factor outside, and finally we can find out it will be like 1 minus mu, right? Tick. Fine. Okay, because here will be sigma s and here will be minus mu, sigma x upon e, then okay, sigma y upon e, then sigma z upon e, right? And it will be sigma and sigma y, right? So this all will come outside and will become 1 minus mu, right? But so it was all about how to find out the strain, net strain in the uniaxial, biaxial, and a triaxial stress system by the help of the Poisson's ratio. Okay. Now in the next lecture, I will be explaining you how to find out the volumetric strain. Okay. Thank you very much.